Hello and welcome to this section of the Chemistry Tutor. In this section we're going to continue our discussion of redox reactions, and specifically we're going to talk about using the half reactions and figuring out what is being oxidized and what is being reduced from the half reactions. Because again, you can have a long redox reaction. What we're doing with the half reactions is breaking it up into two half reactions. One of those reactions is going to be an oxidation process. The other is going to be called a reduction process. And so you have to have oxidation and reduction going on at the same time in your redox reaction. So when we split the big reaction up into half reactions, we should get one that's oxidized and one that's reduced. So let's just take a few examples of these little half reactions and see if we can figure out from looking at it if it's an oxidation process or if it's a reduction process. And the first thing I want to do before I get there is just say that I have replaced our definitions of oxidation and reduction on the board with these sort of simplified definitions, sort of like just abbreviated a little bit to get them on the board in a small space, and I'm going to leave these up because I really want to drill this in. So just to refresh your memory, the oxidation process is when you lose electrons. That's what we call the process of oxidation, is when something loses electrons. If something is undergoing an oxidation process, it's also called a reducing agent in the reaction, because a reducing agent is the thing that donates the electrons. If something's undergoing reduction, that means it's gaining electrons and accepting those electrons, and because of that, it's also called an oxidizing agent. That item that we're talking about, whatever's being reduced in the reaction, is called an oxidizing agent because that's the thing that's accepting the electrons. I'm trying different ways to explain this to you so that you can kind of get the point across, but the bottom line is you have oxidation, losing electrons, reduction, gaining electrons. These agent definitions are just another way of renaming the exact same thing. And you have to learn both of them when you talk about chemical reactions in the redox world, because a lot of times your book will talk about the oxidizing agent or the reducing agent, and you need to know what they're talking about. So let's get started. Let's look at a reaction real quick, a half reaction I should say. What if we have lithium, which is a positive ion? Let's say that we have something like this. And the question I have for you is this an oxidation process or is this a reduction process? Well, here we have lithium ion, so it's already a positive charge. An electron comes along with that lithium ion, and out comes a neutral lithium atom. So we have a single +1 charge here, we have the electron, which is -1, combining, we get a neutral result. So what we have is some item that is accepting electrons. It's gaining an electron in this process. So this is going to be called a reduction process. So that's what we need to write down. So this is called reduction. Really, in order to identify oxidation or reduction, all you have to do is look and see, is the item you're talking about taking in electrons or is it donating electrons back into the solution or whatever we're talking about. So let's say number 2. Let's say we have 2 iodine ions, and that just yields I2 plus 2 electrons. Iodine is one of those diatomic molecules. Usually you see it exists as I sub 2. So what we have is, and this is balanced, notice, because we have 2 iodines, and so on. So what we have to figure out is from the reaction here, is this oxidation or is it reduction? Well, we have a species, and what we see is, yes, we end up with a neutral guy, but what ends up happening is some electrons split off from the original ion we start with. So some electrons are leaving the scene of the crime, so to speak. So we're losing electrons. And because we're losing electrons, this is called an oxidation process. And you can see that from over there. So oxidation. So basically in these half reactions, if you see electrons leaving the scene of the crime, we start with something and then you end up with something electrons are leaving. That's losing electrons. That is electron donation. And so that is oxidation. All right, now what if we have H2 yields 2 hydrogen ions plus 2 electrons? Now make sure you understand what's happening here. We have H2, that's a diatomic molecule, 2 hydrogen atoms bound together. And then we have the reaction where 2 of these electrons peel off because we have 2 hydrogen atoms. 1 electron comes from each of the hydrogen atoms there. What we're left with is 2 hydrogen ions. So 2 electrons peel off, 1 from each atom, so we're left with 2 ions, each with a charge of +1. Because if you look at your periodic table, Hydrogen really likes to be +1 when it can because it's in that first column there. And each of these ions does have a charge of +1. But is this an oxidation process or a reduction process? And if you look at it, the original species we have is electrons are leaving the scene of the crime, changing it into something else. So they're off going on to something else, so this is oxidation. It's an oxidation process because this hydrogen atom is losing electrons. And then finally, let's say we have something like iron with a charge of +3 plus an electron gives this iron with a charge of +2. Is this oxidation or is this reduction? This is a little different because we're starting with an ion and we're ending with an ion. But notice what's happening. This has a charge of +3. This means that in this state, iron, which is a neutral atom, has already lost 3 electrons. That's why it's +3. So we gain an electron here, and when we do that, we change the charge from +3 to +2 because we have one more negative charge in there, and that's going to change the net charge on this guy back up to +3. If we had gained 3 electrons here, it would make this iron neutral again, but we did not gain 3 electrons. We only gained 1. So we still have a charge on the iron, but it's a +2. It's getting closer to 0 as we add these electrons back in. So since this guy is accepting electrons or gaining electrons, then we call this reduction. So here I'm doing 2 things with these sorts of problems. The first one is we're identifying oxidation and reduction, and you can tell that straight away just from how it looks. Here you're gaining electrons, so it's a reduction. Here you're losing electrons, so it's oxidation. Here you're losing electrons, so it's oxidation. Here you're gaining electrons, so it's reduction. And the second thing we're doing is we're learning how to read these half reactions. To see the charges, you know, up until this point in chemistry, haven't seen a lot of ion charges in our reactions. But this is what this is illustrating. You know, hydrogen is 2 atoms. We get 2 hydrogen ions plus 2 liberated electrons. So it's giving us an opportunity to study that and learn how to read these half reactions. So I want to do 2 things with the next set of problems. I'm going to put a reaction on the board that's not completed, and I want to figure out how to balance it, how to make it make sense. And then I want to figure out if it's oxidation and if it's reduction, and also is that species an oxidizing agent or reducing agent. So we're just using our definitions. You know, and definitions is 99% of everything you learn in chemistry. So let's say you have some chromium, which is a solid, and let's say it ends up becoming chromium but with a charge of +3, and let's say this is an aqueous solution. Okay? Now there's obviously something missing here because you can't just spontaneously go from having a neutral atom of chromium to an atom with a charge of +3. Something has to happen there in order for the new ion to have a charge. What needs to happen? Well, this chromium needs to lose some electrons. So if it loses those electrons, then it's going to have a net positive charge. How many electrons does it need to lose? Well, it's pretty clear because this is a +3 charge. What needs to happen is chromium really is going to end up being 3 plus 3 electrons. This is a balanced half reaction. The reason we call it balanced is because it's balanced with respect to both the atoms. See, we have 1 chromium atom here and 1 chromium atom there, but also in regards to the charge, because here we have a situation where we end up with an ion and we have to account somehow for how this ion came about, and so this guy liberates 3 electrons there. So we have a balanced half reaction here because we have the atoms balanced, the chromium's balanced, and we're taking account to what's going on with the electrons. 3 electrons are gone away. Now, is this oxidation or reduction? Well, this is a situation where chromium is losing electrons, right? It's losing electrons because it started with a neutral atom. We end up with an ion plus some free electrons. So this is an oxidation process. Okay, this is a process of oxidation because chromium is losing electrons. Now the other question is the chromium atom that we started with, is it an oxidizing agent or a reducing agent? There's 2 ways to do this. The easy way is just once you figure out if this is an oxidation process, you automatically know that it's a reducing agent. And you know that because of the way these definitions are set up, but once you know it's an oxidation process, you know that what we're talking about here, the chromium, is automatically a reducing agent. I told you that before. Once you figure out what kind of process it is, just flip to the other term, and that's the agent that you have. So it's a reducing agent. And to convince yourself it's a reducing agent is whatever we have in the reaction that's donating the electrons. It's just another word to say, when you have a reducing agent that you're talking about, it's just another way of saying that that thing is being oxidized. Because when something's being oxidized, it's giving up electrons, which is exactly the same thing that we call a reducing agent. They're kind of synonyms, really, is what it is. So that's what's going on here. So chromium is the thing that's donating the electrons, so it would be the reducing agent. Now, this is only a half reaction, so we don't see the other half. We don't see where these electrons are going and combining with, because this is just a half reaction. But in a real reaction, this would be the oxidation process, and then we would have another half reaction which would take those 3 electrons that are liberated, and there would be another process that would be a reduction process where those 3 electrons would be coming in and being gained. So this is just a half reaction here. Okay, so let's go and do another guy here. Let's say we have nickel with a charge of +3. And let's say that we end up getting nickel with a charge of +2. Now obviously there's something missing here, because anytime you have an ion that has a charge that's changing, there has to be something going on with some electrons along the way here. Okay, now this is a positive charge. The only way I can make it less positive like this is if I end up adding electrons. So here I have, let me go ahead and switch colors to make it a little bit clearer. We'll do red like we did last time. So if I have nickel 3+, all I have to do to it is add an electron to get me nickel 2+. Make sure you understand that. So here I have +3 charge on my nickel. So that means this nickel is a neutral atom that's lost 3 electrons. If I add one of those electrons back, I'm gonna go less positive, so to speak, more towards neutral, and I'm going to end up with a charge of +2 on the nickel, because every time I add electrons back in, I'm making this thing more and more neutral. So I come down a level to +2 like this. So the question is this an oxidation process or is this a reduction process? Well, if you look at our definitions, oxidation is when we lose electrons, reduction is when you gain electrons. So here I have this nickel ion, it's gaining an electron, so clearly this is called a reduction process. All right, this is a reduction process. Now, is this nickel ion that we're looking at, is this an oxidizing agent or a reducing agent? And the easiest way to figure that out is to go and realize that once I know this is a reduction process, then I can say that nickel is an oxidizing agent. You know, just like up here when I said chromium, right here, is the reducing agent, the nickel ion, the thing I started with, is an oxidizing agent, because an oxidizing agent is just something that accepts the electrons. In this case, I'm accepting the electrons and I'm getting a new ion at the end of it. So this is a good introduction to half reactions, trying to understand what half reactions look like, and also basically balancing half reactions and trying to make them balance for both mass. That's what we're usually talking about balancing. We're trying to figure out, make sure the atoms are the same on both sides of the yield sign, but also trying to make sure that the charge is balanced. If this +3 ion somehow gets less positive, the only way that can happen is if an electron goes and jumps into this atom and takes its position in there. And if I add, in this case, if I take this guy and I add another electron to it, then this is going to be a +1 charge. And then if I take and add a third electron to that guy, then I would end up with a neutral nickel atom. All right, so make sure you understand the concept. Make sure you know how to apply the oxidation reduction definitions. So look at a half reaction, look at which way the electrons are going, and figure out if it's an oxidation or reduction process. Once you know the process, you automatically know if the thing you're talking about is a reducing agent or an oxidizing agent, because it's basically the opposite agent, okay? And that just comes from the way things are defined. Follow me on to the next section. We'll get a little bit more practice with half reactions and identifying if they're oxidation or reduction processes.